Alright, January 19th through the 22nd. We're looking at lesson 20, modeling riverbeds with polynomials. Our goal is to learn how to fit polynomial functions to data values. Alright, so what I want to do really quickly is I just kind of want to look at the discussion here. Couple of vocabulary words that I want to give you so that we can hopefully understand this problem a little more. Flow rate, or the volumetric flow rate, is the volume of fluid that passes through a given surface per unit time. Alright, a riverbed is the channel in which a river flows, and the cross section is a two-dimensional view of a slice through an object. Alright, so let's kind of look at this. We're going to read through this modeling exercise here. It says the Environmental Protection Agency, or the EPA, is studying the flow of a river in order to establish flood zones. The EPA hired a surveying company to determine the flow rate of the river, measured as volume of water per minute. The firm set up a coordinate system and found the depths of the river at 5 locations, as shown on the graph below. After studying the data, the firm decided to model the riverbed with a polynomial function and divide the area into 6 regions that are either trapezoidal or triangular so that the overall area can be easily estimated. The firm will need to approximate the depth of the river at 2 more data points in order to do this. Alright, so let's look at this. Here's the data that we have. Alright, so what is the goal here? Well, the goal is we need to find the flow rate of water through the riverbed. That's what they're trying to do. Alright, how can we estimate the flow rate of water? Well, you know, it talked about area, so we need the area of the cross section and the current speed of the water. Then the flow rate is the product of the cross-sectional area, or in square feet, and the speed of the water in feet per second. To estimate the area of the cross-section, what information do we need? Well, we have to have enough data points to make a good estimate. And that's why it says we need to find the depth of the river in 2 more data points in order to do this. Alright, so to gather enough data points, we need to make an assumption that the riverbed changes smoothly between the data points that we have. With that assumption, we can estimate other data points by approximating the curve of the cross-section using a polynomial function. So what is our first task? Well, we need to find a polynomial function to fit the data. Alright, so we're going to draw a graph of the polynomial function that passes through the 5 given data points. Alright, so we're starting at 0, 0, and we're just going to basically play connect the dots. Okay, so that's what it would look like. Now, we have 5 data points. What information are we missing? We've got data points here, 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 and here. What are we missing? We are missing the data point at 40, and we're missing the data point at 80. Alright, so we're missing the depths at x is equal to 40 and x is equal to 80. How can we find those missing values? Well, we need to find a polynomial function that fits the given data and then use its equation to find where p is equal to 40 and p is at 80. Alright? So let's think about this. What's the lowest degree polynomial that we could use to model this data? Well, think about this. We've got how many maximums and how many minimums? Well, we have 3 maximums. Alright, we have 3 relative maximum and minimum points. So therefore, we know that we're going to have at least a 4-degree polynomial. Alright? So, what is our constraints? In other words, what do we know about this? Well, we know that when p is 0, or when x is 0, we get 0. We know that when p is 20, we get negative 20. Alright, all I'm doing is listing what I know. We know that when p of 60, we get negative 15. So when x is 0, y is 0. When x is 20, y is negative 20. When x is 60, y is negative 15. Alright, we know p of 100, we know that gives us negative 25. And we know that when p is 120, we're going to get back to 0. Okay. So it says draw the 4 trapezoids and 2 triangles that will be used to estimate the area. Okay, so guys, look at this. Now it's just a matter of visualizing. If you will visualize, first of all, what's a trapezoid? A trapezoid is a 4-sided figure. Alright, it's not a rectangle, it's not a square, because not all 4 sides are parallel. But if you will look at this, here's my first triangle. There's a triangle. Here's my second triangle. Alright, here's a trapezoid. Here's a trapezoid. Here's a trapezoid. And then here's a trapezoid. Alright, so I've got 4 trapezoids and 2 triangles that we will use to estimate the area. Okay? Alright. So we're going to look at what we would do here. We know, let's see, we said that this was going to be the lowest degree would be a 4 degree. Okay? So we know it would have to be a 4-degree polynomial. In other words, an x to the 4th, and on and on and on. Okay? Now, we're not going to, just yet, we're not going to look at the area of this just yet. Example number 1. So we're going to look at this 2 different ways. Alright? So we're going to find the equation by setting up a system of equations. Alright? And then we're going to look at different thing, or another different way. Alright, so before trying to find a polynomial function whose graph goes through all 5 points, let's try a simpler problem and find a polynomial whose graph goes through just 3 points. Alright, so we're going to look at, find a polynomial p such that p of 0 is equal to 28, p of 2 is equal to 0, and p of 8 is equal to 12. Alright? Alright. Looking at these 3 points, will the polynomial function that we find through these points be linear? Well, looking at these 3 points, I've got 0, 28, I've got 2, 0, and I've got 8, 12. There's no way for me to draw a straight line that will connect all 3 of those points. Alright? They do not lie on a line. So what do you think the lowest degree polynomial we can find that will pass through the 3 points? Alright, remember, look at the location of these points in the plane as you decide the lowest possible degree. Alright, so thinking back about what a quadratic polynomial looks like, we are probably going to be able to fit a quadratic polynomial to these points. Alright, in other words, it looks like it might lie on a parabola. Alright, a parabola. Alright, so how would we do this? Well, you can use a system of equations by plugging in x and p of x values into the equation p of x is equal to ax squared plus bx plus c, as you did in lesson 1. Now I realize that lesson 1 was a long time ago, but let's think about this for just a second. So let's see what we can do here. Since p of 0 is equal to 28, then I can say that c is equal to 28. Okay? So, now I've got p of x is equal to ax squared plus bx plus 28. Alright? So I know that p of 2 gives me 0. Alright? So, what can I do here? Well, I can plug that in. Alright? I can plug that in. So, since p of 2 is 0, that's going to give me, let me draw these arrows here, that way we can kind of keep track of what's going on here. That's going to give me 4a plus 2b plus 28 is equal to 0. So that would give me 2a plus b is equal to negative 14. And I just divided everything by 2 because I want to be able to solve for b. Alright? So since p of 8 is equal to 12, alright, then let's go ahead and do this. So I get 64a plus 8b plus 28 is equal to 12. So 8a plus b is equal to negative 2. Alright, now I have a system of equations here. Alright, so I'm going to subtract 1 from 2. So I'm going to subtract, this is 1 and this is 2. I'm going to subtract that and that gives me 6a is equal to 12, which means a is equal to 2. Alright, and I can substitute to find b. Alright, so I know what a is. A is 2. So I have 2 times 2 plus b is equal to negative 14. So when I do that, b is equal to negative 18. So my equation would be p of x is equal to, we said a was 2, x squared, minus 18x plus 28. Okay? Now, let me show you a different way to figure this out. I don't know if you will find it easier or more difficult or what, but I'm going to show you a second way that we could figure this out. Okay? Paper. Back out just a little bit. Okay. So we're going to use the first data point. Since P of 0 is equal to 28. Alright? The remainder theorem tells us that for some polynomial A, that P of x is equal to x minus 0, ax plus 28. Okay? So, I'm going to look at this, and I'm just going to simplify it as x, a of x plus 28. What do we know about the degree of the polynomial a, and how do we know? Well, since p is going to be a quadratic polynomial, a must be a linear polynomial. Alright, so now let's use our second data point. So when p of 2 is equal to 0. Now we're going to plug that in. So P of 2 is equal to, plug it in for x, 2a of 2 plus 28. Alright. I'm going to set that equal to 0. And that gives me 2a of 2 is equal to negative 28. Divide by 2, I get a of 2 is equal to negative 14. Alright? So the remainder theorem tells us that for some polynomial b, then I know that I've got x minus 2, b of x minus 14. So what do we know about the degree of polynomial b? How do we know? So since it's a linear polynomial, then b of x must be the constant polynomial. So I'm going to rewrite this. Once again, guys, I know this is a little confusing. Just stay with me. Alright? So now I've got x minus 2, because we said a of x, alright, b of x minus 14 plus 28. Alright, so I'm just kind of substituting in what I know. Alright, so we've got a third point. Our third point is P of 8 is equal to 12. Alright, so we're going to plug that in. So when x is 8, so we have 8 minus 2, b of 8 minus 14 plus 28 is equal to 12. Alright, let's go ahead and simplify this. I end up with 48b of x minus 104 plus 28 is equal to 12. Alright, I get 48b of x is equal to 96. So b of x is equal to 2. Alright. Remember we said the function b of x could be a constant, and we found that b of x is equal to 2 for all values of x. So now we can rewrite the function, or rewrite the function p. Alright, so I'm going to rewrite my function p. So p of x is equal to x, parentheses x minus 2, b of x minus 14 plus 28. Alright, So we get x minus 2, 2 minus 14, plus 28. Do the 3 points satisfy this equation? So in other words, I'm going to put these 3 points back in. We find out that they do satisfy. So for our final check, we're going to write the polynomial that we just found in standard form. So I would multiply everything through, and when I do that, I get 2x squared minus 18x minus 28. Alright, which, like I said, I don't know if it's easier or harder.
Attention please, freshman PE needs to go to the gym at this time. Freshman PE to the gym, thank you.
Just don't stress out about it, guys. I promise it will all make sense. The next couple of lessons are going to work with this in figuring this out. Alright? Alright, so let's finish up this lesson. Find a degree 3 polynomial such that p negative 1 is equal to negative 3, p of 0 is equal to negative 2, and p of 1 is equal to negative 1, and p of 2 is equal to 6. Okay? So let's figure this out. Alright, so substitute point, I'm not going to be able to do anything here for that. And I'm not going to be able to do anything here for that. So we're going to substitute into p of x. Alright. So we have x plus 1, a of x minus 3, okay? Because all I did was I put my x in there, and then my y point, alright? Alright, so then we're going to look at substitution points. So we're going to substitute it in. And so we get 0 plus 1, a of 0 minus 3 is equal to negative 2, because that's what it tells me it equals to. Okay? Alright, so then now we've got a of x is equal to xb of x plus 1. Alright, and now we're going to look at substituting in for p of x. So I get p of x is equal to x plus 1. And then I've got xb of x, plus 1 minus 3. Alright, we're going to come and substitute. Let's substitute 1 negative 1 in. So I have 1 plus 1 times 1b of 1 plus 1 minus 3. Alright. Now we've got b of x is equal to x minus 1 c of x. Alright. And then I've got p of x is equal to x plus 1 times x minus 1 c of x plus 1 minus 3. Alright, substitute 2 and 6 in. So I've got 2 plus 1 times 2 times 2 minus 1 c of 2 plus 1 minus 3, which ends up giving me c of x is equal to 1. So I have p of x is equal to x plus 1, because we said that's what a of x was, times x times x minus 1 times 1 plus 1, parentheses, minus 3. If we were to write that in standard form, alright, then we would figure out if we took p of x and we went ahead and wrote this into standard form, then if I multiplied all of this out, I would end up with x cubed minus x squared plus x squared minus x plus 1 minus 3, which would give me p of x is equal to x cubed minus 2. Okay? And if I want to figure out that it actually works, I would plug my 4 points in and figure it out. Okay. I know that this doesn't make a whole lot of sense just yet. Hopefully the more we work, the better it will be, but we will continue to work more on this. Alright guys, have a great week, and I will talk to you next week.